And these are just some examples of the work that we did using the self-organized map geobody extraction representing specific facies distributions in the form of geobodies in 3D, showing it across large areas. You know, that's more than 100 miles from north to south here in the Delaware Basin. Lots of examples of these facies distributions, and that's what makes it so important. If you can do this sort of facies distributions over that many seismic volumes so quickly and efficiently, right? Now you want to merge it with all of your petrophysical data in order to be able to then link these particular lithofacies predictions to the actual petrophysical data. And that is one of the gold standards. That is the holy grail right there. If we can combine these things, then we can come up with distributions of porosity, permeability, and water saturation through the entire Permian Basin. That's what we're doing right now, right? For those engineers here in the room, for instance, that do reservoir simulation, key to have that information. And tools like 𝗕𝗿𝗄𝗃 actually help us get there much, much faster than any other technique that I've ever used in my entire career. So merging the actual lithofacies predictions with the petrophysical data is the holy grail. What I did is I basically took the software and tried to validate it for myself. And when somebody says, okay, we've got a revolutionary new tool that can do better lithofacies prediction, well then, one of the things I usually do is I grab one of the projects that I've done in the past, and I just run the software. So Charlie Cairns and I put together a model in the Midland Basin that was in a field owned by Oxy, Midland Farms Unit, where we developed an entire workflow to identify what you see right here, ooid grainstone distributions in both the San Andres. So all of those complex structures right there of great interest to all of the operators operating in the Permian Basin. And of course, the 𝗕𝗃𝗃 has been the host to many, many large reservoirs. So Charlie and I basically, we used his core data, combined it with my workflows in the ELISE PaleoScan software in order to come up with a much higher resolution model for the actual stratigraphy. And if I'm not mistaken, this particular little video shows a large area of the Midland Basin. We're looking towards the north, and you can see from these colors of this acoustic impedance straddle slice how the actual progradation, you know, and the retrogradation of these various interfingering layers are basically documented through time. So what you're looking at is a very complex geological depositional environment that we're effectively modeling in time in order to be able to get a much better three-dimensional stratigraphic framework that we can then be merged with petrophysical data in order to become much more predictive. So doing all that work in ELISE and PaleoScan and building all of these layers and stuff like that, ultimately to be able to create these ooid grainstone geobodies, right, which are targeted for a production, or in some cases are very tight, and then relate to the saltwater disposal, fairly time consuming, but ultimately we can get to a point where we can get very quantitative about these ooid grainstone geobodies, and that's absolutely critical for the exploration and development of this field. So ultimately, that particular study took Charlie and me approximately 9 weeks before we were able to then cut into one of these ooid grainstone geobodies and look at the actual porosity and permeability distribution within one of those. Basically, ran the exact same workflow that I just showed you, and I'll skip over these slides because we're going to get into lots of the detail of the self-organized maps and the lithofacies here in a little bit, right? Here you can see all of the volumes that I used in order to be able to condition the self-organized maps. And these are the well logs that I used, as well as the facies distributions. And then basically what I came up with in 𝗕𝗿𝗃𝗃 and what it helped me facilitate is link the neurons from the self-organized map exercise to the actual petrophysical facies data from my well logs. Right? And that enabled me to create the same sort of cliniform ooid grainstone geobodies in this particular field from Oxy in the Midland Basin. Right? And then I had a chance to compare that against our core data, validate the actual accuracy thereof, and here's some views from the 𝗕𝗿𝗃𝗃 software that enabled me, and then look at the three-dimensional distribution, the connectivity and the continuity of these various grainstones in 3D, and I was able to replicate the exact same work on coming up with these three-dimensional grainstone distributions, right? So critical for the development of this field. But instead of using, 3 weeks, or maybe even more time, considering all of the work running up to it, and I did it all in under 12 hours. Then I went back and I compared it to all of our previous data. We looked at the distribution of the core data, and we saw that the actual results from the lithofacies distribution from Paradise were much more accurate than any other technique that we have used theretofore, including a wide variety of geostatistical techniques.